Hello. So this is a video for COMP345. This is for week 6. This is lab number 6. So this is explaining an example that I designed for the MVC architecture as well as the observer pattern. So if we go straight into the code here, so maybe I can show where I'm taking this, just make sure people understand here. So if you go to the web page or the Moodle, you'll be able to find lab 6 here. That's this code here that I'm showing. Okay, I've already imported it inside of my Visual Studio here. So I have all of these H files and all these CPP files here. So I'm going to start with the driver here, the clock driver, which contains my main function. So what is happening here is that I have my model view controller. So the model is essentially this clock timer here. The clock timer, what it does is essentially a clock that contains hour, minutes, and seconds, as well as a certain value that I maintain. Clock timer here. It contains the timed interval that it is counting as the user is entering this value on the user interface. So it will start. So it allows the user to set the current time of the timer by using set time. And then it also allows the user to set this timed interval that is essentially the number of seconds that the timer is going to count when the user asks it to start. Okay. So for example, you can set it at midnight and then tell it to count for 5,000 seconds. So it's going to basically increment 5,000 seconds starting at midnight. Okay. So that's what this timer does. So you see that if I want to make it a model object, then what I need to do is to make it a subclass of subject. So subject is the superclass or the base class, or one of the base classes of the actual, in this case, the only base class of the clock timer class that I had created. That's one of the only things that I have to add to this existing clock timer to actually make it a model object. I make it a subclass of subject. What subject does or provides to my clock timer is that it provides with attach, detach, and notify, which is the communication mechanism that is implemented between the subject and the observer classes. So I make my model object or my clock timer object a subclass of subject. So it reuses these methods that are defined inside of subject. And then I will make my view, my digital clock, a subclass of observer. And then it will actually reuse this code here. So that would actually make this object and this object able to interact with one another through these two classes here that provide the implementation of the communication mechanism. So the subject actually provides the model with a method to attach itself and detach itself to the actual view, and then a method to notify its views if there is more than one. So you see that the way that it implements, if we look inside subject.cpp, then you see that if you attach it, then it actually pushes the observer into this underscore observers list. Even if you detach, then it actually removes it from the list. Then if you see when you call notify, it actually uses an iterator that iterates over the list of observers, starts from begin and then calls update until the end. So it goes over all the observers that have been attached and then calls update on them. Okay. Now, what is update? Update is one that is implemented inside of the observer abstract class. So the observer abstract class is an abstract class. How do you know that is an abstract class? So in Java, you might remember that when you declare an abstract class, you would use the keyword abstract. There's no such thing in C++. You don't have the abstract keyword. What is an abstract class? It's a regular class that has at least one of those pure virtual methods. What is a pure virtual method? It's a method that is declared as virtual. As we will see these concepts later when we talk about polymorphism, how to do polymorphism in C++. If you want to use polymorphism, you must have virtual methods. So this method is a virtual method. So polymorphism is enabled on this method. Plus, it's not only a virtual method because it has this equals 0 here. It makes it what is called a pure virtual method. What's the meaning of the equals 0? It's basically that it says that there's no body. Don't look anywhere for a body or definition of this method. This class will not provide any definition for this method. Okay. So essentially, that makes this class an abstract class. Okay. So essentially also what we're doing somehow is that we're creating some kind of interface, which is the observer abstract class that forces all of the subclasses of this observer class to implement this method update. So that's what is the notion of an interface in Java. It's a class that forces its subclasses to implement a list of methods that it does not provide, it does not provide an implementation for. So hence, if you inherit from them, you have to provide the implementation. That's exactly what this class is doing here. If you inherit from observer, you inherit from this method here, which does not have an implementation, so you must provide one. We will see these concepts later on, starting next week. Okay, so my model object or my clock timer is my model object. It is a subclass of subject, which makes it able to use the attach, detach, and notify. And then my view, which is my digital clock, actually implements, or not implements, but inherits from the observer abstract class, which forces my digital clock to actually implement the method update. If we look inside of the digital clock class, what the update method does, it actually calls this method display here, which what it does is actually it gets the hour, minute, and second from the clock and then displays it on the program console. Okay, so you see that my observer is very simplistic here, basically outputs something to the program console. Of course, in real life, you would do more complex things like having a window and so on and so forth. This one is very bare bone, I might say. Okay, so what if we go back to my clock driver here? So here, first thing I do is create my clock timer object. So then the constructor for clock timer is being called. So that's clock timer constructor is here. So that basically initializes hour, minutes, seconds, and time interval to 0. So that's what this model object is. It's a clock that is now all zeros. Okay. Of course, as this clock timer inherits also from subject, the subject part is actually created also, which would make these methods available to my clock timer. And now, of course, my clock timer also has this list of observers also that it inherited from the subject. That's how my clock timer is connected to my view, because it has this list of, it maintains this list of views that are connected to it through this inheritance that it inherits this list from the subject class. Okay, let's go back here. So my clock timer has been created. It is a clock timer and it's also a subject. And then here I create my digital clock. My digital clock is my observer object. And then it must implement update because it is inheriting from this observer abstract class. And you see that if you go to observer, observer does not provide anything to this class. It does not provide the clock time, digital clock. Digital clock here has everything that it needs to function. Observer is inherited. The only reason why it's inherited is to basically force the digital clock to implement this update method. Okay. Then, oh yeah, so as you call the constructor for clock controller here, no, here, sorry, for digital clock. So you call the constructor of the digital clock, you pass it a clock timer. What it does is essentially it attaches the clock timer to the digital clock, thus making the connection between the digital clock and the clock timer. Okay. So that when you call that, when the clock timer is going to call notify, the notify is going to call update of the digital clock. And then update is going to run that here and then interrogate the digital clock with the new state and then display this new state. So you see that there's this communication mechanism that is provided by both of their superclasses, their respective superclasses. Let's go back to the driver. So here I've created my clock, and then I created my view. My clock is my model. I created my view here, which is my digital clock, and I passed the model into it, which is then this constructor attaching the model to the view. Then last step is I need to actually create my controller and create this connection here between the controller and the model and the controller and the view. So that's done to this constructor here, the clock controller constructor, clock controller, constructor. Basically, what it does is that it receives the view and the model and actually instantiates its local variables that is actually using here. Because, for example, when you call control clock method, then it's going to call the methods inside of the clock model that was actually instantiated here in the constructor. The clock model that was passed to the constructor here is going to be called here. Okay. And then, of course, it is connected with the view to have this other connection here. Okay. So create the model, pass the model to the constructor of the view, create the view, and then pass both of them to the clock controller, connecting all these three things together. So then when I call control clock on the controller, and what it does is basically interacts with the user. If we, maybe I can run it. So that's what it shows to the user. For example, let's say I want to set the time. I go 1, and then let's say 12, 12, 12. So you see that here what I did is to call 1, 12, 12, 12. So that's option number 1. So here basically I entered these 3 values here, values 12, 12, 12, that I actually call set time 12, 12, 12 inside of the clock model, which is itself, yeah, I have to stop the execution here. It calls set time of the clock timer here, which is setting the hour, minute, and second to 12, 12, 12. And then calling notify, because the state of the clock has changed, I call notify. Remember what notify does is actually notify is going on the over the list of all the observers. In this example, I have only 1, but there's still a list. There's one element list, and it's called the update of the digital clock. What digital clock update does is it calls display, which interrogates the clock and then displays the new time. So if I repeat it, 1, 12, 12, 12, it displays the time. Okay. So that's here displayed due to the operation between the subject and the observer. Now, if I go 2 and then 30, say 30 seconds, so it will count for 30 seconds. If I press start, so it starts at 12, 12, 12, and then increments 1, 2, 3, 4, 5 until it reaches 30. So that's basically every time that I call tick inside of the clock timer. So when I say start, controller, when I chose option number 3, what it did is it's called start in my clock timer. What clock timer start does is it counts from 1 to time interval and then calls tick. And then tick actually incremented 1 second every time. And then every time will actually call notify, signifying that the state has been changed. And notify will call update on my view, which would then interrogate the timer and then redisplay the time. So that's why I display the time every time tick is being called. Okay. So you see that here, I'm not actually using cout or anything. This code here doesn't even know that it's being observed. The only thing it does is call notify. And also it does implement, or it does inherit from subject. Okay, so you see that's very low the intrusion of this addition that I made to this code is very low. I had to make this class here a subclass of subject, and I needed to call every time my state is changing, I actually call notify, which then calls update on the view and then redisplays the information. So let's go back to the driver. Oh, let's go to the controller. So that's about it. So you have here, the separation of concerns is very important. So you see that my user interaction here is totally concentrated into my controller object. If you even look at the clock timer, there's no user interaction here. Clock timer, there's no user interaction. It's only a mechanism. It's a clock, increments seconds. The only thing it does is called notify. You don't have user interaction in here. You don't even have user interaction in digital clock. The digital clock, all it does is it displays information, and then it provides an update method, which will be called by the the notification mechanism. Okay, so here this is only concerned with displaying information. The controller is only concerned with user interaction, and then the model is only concerned with the execution of the business logic of the application. Okay. So that's what is the MVC architecture as implemented in this example. So that's it for that. Thank you.